Okay, so today we are moving on from parabolas. Remember we had the left and the right, the up and the down. Now we are moving kind of back into circles, and we are going to deal with this guy who is known as an ellipse. Okay, basically ellipse is a fancy name for an oval, as you can imagine. It is basically an oval. There are two different ways that you can see an ellipse. We have a horizontal ellipse, one that is wider than it is tall, and then we have a vertical ellipse, one that is tall and not so wide. If you think back to our circle equation, okay, our circle equation was x squared plus y squared equals 1. Okay, and then we moved the center away from 0, 0 by putting the opposite with the x, so it was like x plus 4 squared, actually moved it to the left 4. Okay, same thing is going to happen here. Okay, it's basically the same exact thing as a circle, except look at what's going on underneath. Okay, since our ellipse doesn't have a radius, it's got two different lengths from the center out to this side and then the center up to the top. Since they're different, you are going to do the same thing we did with a circle. We squared the radius, except that the horizontal length from the center out is going to go under the x, and the vertical length from the center up is going to go under the y. Okay, so let's see what I'm talking about. It's probably easier just to go ahead and jump right into some examples. Okay, so if you look at this guy right here, okay, he is definitely horizontal, so he is long ways. Okay, he is laying down. So our center is sitting at 0, 0, so we don't have to mess with that. Okay, he is sitting at 0, 0. Don't let these confuse you. Okay, because it says a squared, b squared, whatever. Do not let that confuse you. Okay, the easiest way to remember it is the length from the center out, which is staying on the x-axis. Square it, it goes under the x, whether it's a vertical or a horizontal. Okay, the center up, since we are on the y-axis, stays with the y, whether it's vertical or horizontal. That part never changes. Okay, so let's see what we have here. I am at 0, 0. So it's x squared plus y squared. Ellipses always equal 1 because with a circle we have the radius right here, and ellipse is always set equal to 1. Okay, so now we're going to stack it. And let's see how wide my ellipse is. From the center out, looks like it's 8. 8 squared is 64. And its height from here up looks like it's about 5. And 5 squared is 25. Okay, pretty simple there. Okay, major versus minor axis. Okay, your major axis is going to be the bigger one. Okay, major is bigger. Okay, since we are turned sideways, our major axis is going to be this entire length right here. Okay, so basically you can take what you got for this and double it. So 8 times 8 is a full length of 16. Or you can count. You have 8 plus another 8 is 16. Okay, the minor axis in this case is the opposite direction. Okay, so our minor axis is 5 plus another 5, which is 10. Okay, to get the foci, I want you to write this out to the side. Okay, it is a squared minus b squared equals c squared. It's kind of like doing Pythagorean theorem back in middle school. Okay, but I want you to remember, don't worry about horizontal, vertical. It's always going to give you a positive answer. Okay, so it's always got to be big minus little and take the square root. Okay, so what do I mean by that? Well, that means that 64 minus 25 and take the square root. Okay, 64 minus 25. It's going to give you the square root of 39. Okay, and that gives you an ugly decimal, so we'll just leave it as the square root of 39. Okay, our foci are actually points that are right here along the major axis. Okay, foci are always on the major axis. Okay, so that means it's going to have an x value of whatever this is, and a y value of 0, because we're not going up or down anywhere. We are going to be along that axis. Okay, so we'll have one there, which is the positive square root of 39, and then the exact opposite. Okay, so he's over here somewhere. Okay, basically the foci is basically kind of like our rotation. Okay, that's where if we were to stick our pencil in here and act like we were going to draw this ellipse, kind of like y'all used to do in elementary school, where you would put a pencil here and then a string, and then your string would help you draw the circle. This is the turning point of the corner. Okay, because of the fact that it's not a perfect circle, this is the turning point of that corner. Okay, so let's move down to a vertical one. Okay, again, don't worry about who's A, who's B, whatever. Okay, our center is at 0, 0. Okay, this time we're going to talk about who is the up and down. So our Y is our height. Looks like he is 5 tall. 5 squared is 25. And our width is right here at 2. 2 squared is 4. Okay, in this case, our major axis is actually our Y. Okay, because he is the taller one. Remember, the major axis is bigger. Okay, so in this case, we have a 5, which means that it's 5 on this side too. 5 plus 5, our major axis is 10. Our minor axis, 2 plus 2, which is 4. Okay, on that same note, okay, our foci are now going to be on this y-axis. Okay, if my foci are on the y, that means I have an x-coordinate of 0. Okay, and to figure out where my y-coordinate is, remember it's big minus little, and you take the square root. So I have 25 minus 4, and I take the square root of that. Okay, again, it's going to be an ugly number. It's actually the square root of 21, which is not a perfect square. Okay, the square root of 21 is about 4.5, so our foci are going to be up here somewhere and down here. Okay, so I have the positive square root of 21 and negative square root of 21. Okay, so there are your ellipses, horizontal and vertical. Okay, flip it over, let's do another one. Okay, all of these look like they are centered at 0, 0, which is good. Okay, we're going to do the exact same thing we did on the other page. We'll write the equation, major, minor axis, and state the foci. Okay, in this case, it is a horizontal one. We are at 0, 0, so x squared plus y squared equals 1. The width of this, so from 0 out to here, is 7. 7 squared is 49. Okay, and from the center up, it is 2 units. 2 squared is 4. Okay, with that being said, remember our major axis is the entire distance, okay? So from one side all the way to the other. So 7 plus 7 is 14. And the minor axis, 2 plus 2, which is 4. And to find our foci, remember they are going to be on the x-axis, okay? They're on this major axis, so that means that our y-coordinate is going to be 0. And to get that, we do big minus little, take the square root. So we have 49 minus 4. Square root of that is actually the square root of 45. Okay, I'm not going to break that down to a decimal. Decimal-wise, if you want to know, it does end up being about almost 7. So they're way out here on the edges. Okay, we have the positive square root of 45 and negative square root of 45. So here, and then the guy that I graphed down there. Okay, let's keep going. We have a vertical. Okay, so it doesn't change. X squared plus y squared equals 1. We are still at 0, 0, which is why it's just x squared plus y squared. It's actually x plus 0 squared and y plus 0 squared, but we don't need that. Okay, and let's see what these individual radius are, or radii. Okay, this one is 4. 4 squared is 16. And this one is going to be bigger because it's a vertical. This guy is 6. 6 squared is 36. Okay, so there's your formula for this ellipse right here. Our major axis is 6 plus another 6, which is 12. Minor axis is 4 plus another 4, which is 8. And in this case, our foci are on the y-axis, which means I have an x-coordinate of 0. Okay, and we have big minus little, take the square root. That is the square root of 20. Again, ugly decimal. So the square root of 20 is 4.47, so almost 4.5. So our foci this time are about right here at positive square root of 20 and negative square root of 20. Okay, again, at 0, 0. X squared plus y squared equals 1. Horizontal ellipse all the way out to 6. So he is long and short. Or should I say short and fat, really? So 6 squared is 36. He is actually only 1 unit tall. Okay, be careful, they counted by 2's here. He is 1 unit tall, 1 squared is 1. So there's your equation. Major axis, 6 plus 6, which is 12. Minor axis is 1 plus 1, which is 2. Okay, and again, the foci are going to be along this axis right here. Okay, they're on this major axis, which means that they have a y coordinate of 0. They're on the x. Okay, big minus little. So I have 36 minus 1. Take the square root. So that ends up being the square root of 35. Okay, so I have positive square root of 35, negative square root of 35. Okay, the square root of 35 is 5 point something. 5.9. So they are literally way out here, almost to the 6. So almost to these outermost vertices. Okay, we have another vertical. Center is still at 0, 0. Okay, this time he is tall and skinny. Okay, height-wise, he's all the way up here at 6. So 6 squared is 36. And this time he's only 1 unit wide, so it's basically the same guy, just turned the opposite direction. Okay, so 1 squared is 1. This time my major axis is still 12. My minor axis again is 1. But this time my foci are the exact opposite. Okay, my foci are now going to be on my y-axis. So I will have x value of 0. Okay, the math of this doesn't change. I still do big minus little. So I still end up with the square root of 35, except this time it is on the y. So it's 0 positive square root of 35 and 0 negative square root of 35. Remember, the foci are your turning points. That's where your graph starts to turn and go back the other direction. Kind of the magnetic force that makes you turn, I guess I should say. Okay, flip it over. Okay, for these we're just gonna do the equation, and then I just want y'all to list the major and minor. I don't want you to worry about the foci right now. Okay, so I have my center right here. This one is a vertical. X squared plus y squared equals 1. Okay, I am 5 units tall. Tall, it goes with our y. So 5 squared is 25. And he is 3 units wide. 3 squared is 9. My major axis is 10. Minor axis is 6. Okay, moving on over here, another vertical. Okay, we are still sitting at 0, 0. He is 3 units tall. Vertical goes with the y. 3 squared is 9. He is 2 units wide. 2 squared is 4. My minor axis is also 4. My major axis is 3 plus 3, which is 6. Okay, another one. I'm going to go ahead and kind of start doing these kind of quick, mostly for review. Y'all can pause the video, work them out if you want to, and then come back and check. Okay, but this guy is 7 tall, so 7 squared is 49. 2 wide, 2 squared is 4. My minor axis is 4. And my major axis is 14. Okay, again, make sure you are understanding where the foci would be. Okay, if we were to graph them, the foci would definitely be on the major axes, wherever those are, pushed mostly out to the edge. Okay, they're going to be very close to the edge of these lines. Okay, so way out here on the edge of the minor axis. Or major axis, sorry. Okay, last two. X squared plus y squared. Okay, x squared plus y squared equals 1. Last two for the day. Okay, again, I hope at this point you're working them out on your own and you're just using mine to check to make sure you got them right. Okay, mostly because tomorrow we're going to go into moving them off the center. Okay, so they're not just going to be x squared plus y squared anymore. We're actually going to have to shift them before we figure anything else out. Okay, it's not super difficult, just another step in the process. Okay, and there's the last one for the day. Again, look over your answers. Make sure you're on the right track. Sneak peek, because tomorrow, if you look, we're moving them. We're no longer going to sit at 0, 0. We're going to move them to a different location. Okay, if you look up here at the formula for tomorrow, it's the same as it was for a circle. Okay, opposite direction. Okay, x still stays with h, y is still with k, just like it was for parabolas and circles. Does not change for these guys. Okay? So again, look over your answers, make sure you got them correct. And that's it for today.